Guys, help me out. I guess I'm just thinking about how this unit houses the synths, these synths. Synths each. So it's like that's one synth, and then that's another synth. They're mirrored. So there's 8 synths. 8 synths. So they go in here. Just here. And then like a fan goes in there or something. But you get the idea. And then this is like their tuning bank. So these are multi-selectors, like to get the signal in and then route it to a particular capacitor on the bank. So like you could select like cap A, cap B, cap C, whatever. And so the idea is that like one of them is the route out to the capacitor, and then the other channel would be the route back in from the other side so that you could continue the circuit. But then I realized recently when actually wiring this thing that the circuit just leads directly to ground anyway. So it doesn't actually, like they could all just be wired to one central ground. But nonetheless, anyway, we learn, we live and we learn. But it looks pretty sick. Yes, that gets mounted in here. So it's like bam, 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 down the side. And then I can like tune my synth and they go boom. And then this is the variable caps. And so they fit in here like that. And yeah, I think this one's good. So like this little guy. And then this fits on there. There we go. Like that. But then you can like tune the variable caps, and that tunes the banks of the synths. The synths are cooled. It has the variable caps. It has the main capacitor bank. It has the machine head knobs down the sides. So it's got, yes, the capacitor banks. I guess it's like 2 cap banks per synth. Yeah, and so they're wired in parallel with that, and then that goes back into like the synths hex circuit, which is these ICs, hex inverters, which are just logic inverters. So if you give it a 0, then it gives you a 1, and if you give it a 1, then it gives you a 0. Like, you know, OR, NAND, XOR type stuff, and that, but like in 12 volts. So it's just going like 0 volts, 12 volts. Really quickly. I have another one that's like my test one. These are like these are the nicer versions, but this one was my test one, my dev one. I've salvaged the caps from it, but this is like my ancient one. When I was first learning electronics, I was like, oh, I think I got it right. And then it worked, and it was very cool, and it has these gigantic LEDs on it. But it's very tight. So yeah, that one burnt out though, because I just combined the 2 outputs together and it just blew the ICs. Because yeah, I also may have destroyed one of my like external sound cards with one of these. Steinberg, a Steinberg sound card. Anyway, nonetheless, I'm thinking of putting buttons in the top here, so you can be like bam, 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 bam. This. Honestly, like an on-off right now, it's just like constantly going. Like once it starts, it's just going forever basically. So I really need a way to like turn the signal off. Obviously I could just like break the chain. I'm gonna work out like a good way to do that, but I need a VCA realistically. I need, you know, like CV lines, which would be like a sequencer, and then you could actually like play it like bum 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 bum, like automated sequence kind of thing. But right now it's just honestly just going beep forever. So I think what I would like to do, probably, mount buttons that then kind of like forcefully like drain the power out of the circuit. Like lets the voltage like fade out slowly or something. I don't know, like with a resistor, I don't know, but you could make it kind of go like as the sound like cuts off. Or you could make it like tuned down. If you like reduce the power to the ICs, it would go like boom, 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 boom. But you'd be like limiting and starving the power to the ICs. So there's like drain the power out, which is like, you could also like have a cap like draining power from it recharging or something. So you could control the pitch by starving the ICs, or you could, so yeah, I want to have like a button that's like cut, 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 kind of, if you could control the fading back in power and then fading out as well with voltage, like undercharge the IC, that could be cool. This is the real question, is that everything in the everything in the whole system is analog. And that's like what makes it so beautiful and unpredictable. And because it has like infinite resolution and it has faults. Those things you can't synthesize. So even if it's a bit raw, at least it's got character. That's my view. Like I'm using these like massively overcharged capacitors, like, yeah, 250 volts, like it doesn't need to be rated for that, but I just think it's cool. But yes, it's not optimized whatsoever, and that's like what's beautiful about it. It's going to be a bit weird when I try it. Like even with the previous ones that I tried up here, my test circuit, both channels sounded totally different, honestly. They had like totally different characters. Even though that they were the same circuits. That's what's so weird about it. And that's what's so valuable about it, is that they're all going to be different because there's faults in the wiring. I make mistakes. That's what's great about it. Like this. I'm going to make mistakes. Not to mention the extra long signal connection between this to this to this, the control unit. This is all the parts. So it's gonna have to like run these long distances. It's 12 volts, so it'll be fine, but it's like, I'm sort of hoping that like a little bit of like noise and stuff and like decay happens in the long signal chain. And maybe some interesting effects of this interesting Faraday cage. So I kind of believe that like, cause the universe is like symmetrical and beautiful and like, you know, mathematical and everything, and it understands beauty and symmetry and like all of these like beautiful things that we hold dear, down to the smallest level. Everything is like eddies and patterns and the golden ratio and stuff. So my basically philosophy is that if you are making stuff that is sacred looking, if it has a character about it, like a sacred energy that we can perceive in this, like everyone can perceive if something is like holy or unholy, like good or bad, for just the objective goodness of the universe. Everyone can see that. And if you can see that this thing that you made is good, then something about the electronics within will be different. That's one thing we got to be real about and straight about, is that like SMD components, SMD boards, I wonder if I have any examples around here. This kind of stuff, this is unholy. It's just like inhuman. It's just like this, like it's just like not real. You can see me like Tarzaning this thing, like just like shoving these giant rods into it to try and make it like interfaceable. These kinds of things don't have a good energy, and that's why they are weak. They all sound identical because they're perfect. And this, I feel, has life about it. You can't tell me that using this in a circuit, right? This weird thing that you found. Using these cables would do something divine. Looks like automation stuff. Yeah. Or, I don't know, like this. Like, what is the deal with this? This giant, like, really thick silicon wire. Like, use that for something, makes the circuit sacred. And it's like, by honoring these things properly and housing them right, the universe will reward me with an interesting electrical phenomenon. So that's electronics, basically, is the magic. So it will magically reward me, and you will see. You will see.